Hello students, welcome to my YouTube channel Integrated Physics Studies IPS. एथरे मु ऑलरेडी प्लस 2 सेकंड ईयर सिलेबस कंप्लीट कर सारछि एबे मु प्लस 3 CBCS ऑनलाइन क्लासेस रो वीडियोस गुडा अपलोड करिवि जदि भल लागिला ताले लाइक कर देबो एवं सब्सक्राइब कर देबो जो वीडियोस गुडा मु अपलोड करिवि तार नोटिफिकेशन पई एठी बेल आइकन को ऑल रे सेट कर देबो गोटे इंपोर्टेंट जिंस वीडियोस रो ऊपर एठी जो 3 डॉट्स देखुछो तार क्वालिटी एठी देखो बाय डिफॉल्ट 360 अछि तमे ताकू बढ़े मध्ये परिबो एठी एडवांस रे क्लिक करी तमे रिजोल्यूशन बढ़े परिबो प्रति वीडियोज रे मु पीडीएफ लिंक देबी ताकू एठी ड्रॉप डाउन लिस्ट रो तमे क्लिक करी डाउनलोड मध्ये करि परिबो पीडीएफ को लास्ट रे एठी जो मोर चैनल नेम अछि याकू क्लिक करी तमे एठी प्ले लिस्ट को जाई मु प्रति वीडियोज को यूनिट वाइज एज पर सिलेबस सजाई की रखिथिबी तमे सर्च करि परिबो ओके थैंक यू हेलो स्टूडेंट्स आज रो टॉपिक रे हमें ऑप्टिकल माइक्रोस्कोपी विषय रे पढिबा which is one of the direct detection technique for the characterization of nanoparticles. Now, you know that the nanoparticles or the nanomaterials are so small or teeny in size that you cannot observe them through your naked eye. So, optical microscopy is one of the technique which is used to closely view a sample by an optical microscope through the magnification of lenses with a visible light. Okay, and this optical microscope is also known as light microscope. Okay, and it consists of one or more number of lenses in order to magnify the images of small crystalline samples with a visible light. And here this sample, here we mean that it is having your nano dimension, right? Now the lenses are placed obviously between the sample and the viewer's eye in order to magnify the images and for getting clear detail examination. Okay, so you have also read about the simple microscope and compound microscope in your plus 2. All these belong to your optical microscopy. So besides these simple and compound microscope, there are different types of optical microscope that can vary from a basic design to high complexity. Okay, and they can offer high resolution and contrast. Okay, some of the types of your optical microscope ଯେମିତି କହିଲି simple microscope ଅଛି, compound microscope ଅଛି, ତା ଛଡ଼ା digital microscope, then stereo microscope, comparison microscope, then inverted microscope. Okay, simple microscope, you know this, it consists of a single lens. Okay, and it magnify the image of the sample. Then compound microscope consists of a series of lenses to magnify the image of the sample to a higher resolution as compared to the simple one, right? Thereafter the digital microscope consists of a single or a series of lenses and it uses a computer system. Okay, that's why it is called digital. Okay, in order to visualize the image of the sample without the requirement of an eyepiece to view the image. Okay, thereafter your stereo microscope which provides a stereoscopic image of the sample which is useful for dissections. Then your comparison microscope which allows for the simultaneous view of the two different samples. Okay, comparison means obviously it will compare two different samples. Okay, one in each eye. Then next one is the inverted microscope which views the sample from underneath. So ତଳପଟୁ ଇଏ ଦେଖିବ and it is helpful to examine the liquid cell cultures. Okay, for example ଯେମିତି यूरिन ର sample culture ପାଇଁ ନିଆ ହୁଏ for medical diagnosis. So ସେଥିପାଇଁ ଏଇ inverted microscope use କରା ହୁଏ. Okay, let us now see the schematic diagram of a simple microscope. You know this is the position of your eye, this is the lens which is the convex one, and for a teeny object we are getting a magnified image, right? Thereafter the compound microscope, and here we are using two lenses. The lens which is close to the eye is called eyepiece and the lens which is close to the object is called objective. Okay, here again for a teeny object, this one we are getting a magnified image, but now it is inverted, right? You have read this detail in your plus 2. Thereafter is your stereo microscope. So as we are discussing, stereo microscope କ'ଣ କରିବ ନା it will provide a stereoscopic image of a sample which is useful for dissection purpose, right? तापर रोचे तुमर ये देख comparison microscope. Okay, so here we can compare two samples, right, simultaneously. Okay, so we are taking two different samples and simultaneously we can compare them one in each eye, right? So ये देखो comparison microscope रे ये कहूँ two identical microscope are connected to a single comparison eyepiece. So eyepiece ये गोटे single रहिबो किंतु microscope दुईटा रहिबो identical, right? And the viewer can see the images from both the microscope next to one another. तापर आसुची inverted microscope. This is the schematic diagram, and as we are discussing, it can be used to view the sample from underneath. Okay, तलपटु आमे sample को देखि परिबा याकु यूज करी, and it is helpful to examine the liquid cell cultures. Okay, the next one is the digital microscope. This is the schematic diagram, and remember, digital microscope does not require an eyepiece, right? And it consists of a single or a series of lenses, and it uses a computer to visualize the image. You can see this is the USB cable, so it can be plugged into the CPU or your laptop so that you can visualize the image in the computer or laptop. Okay, so in this way we have seen different types of microscope under the category of optical microscopy. But the important thing is that in order to use the optical microscope effectively, that means in order to get the effective output result, the microscope must be set up correctly. Okay, so we have to ensure this. For this, the objective of the lens of the microscope must be close to the sample, right? So that it will allow the light inside the tube of the microscope, and thereby it will produce an enlarged and inverted image of the sample, which can be viewed through the eyepiece of the microscope, right? Now this optical microscopy, if we see the application, it is used in microelectronics, then nanoelectronics, then nanophysics. Okay, optical microscope can produce up to magnification 1200 times, okay, and resolution up to 0.25 micrometer. But however, it has some limitations also, like number one, the resolution of an optical microscope cannot be smaller than half of the wavelength of light. Okay, so the wavelength of light, the visible light that we are using, so up to half of its wavelength we can resolute, and it cannot be smaller than half the wavelength of light. Then the second point, the optical microscope has low magnification, and the third point, it produces poor surface view of the sample. So this is what the optical microscopy आमे देखिला याको ब्रीफली ए बहिरे जहाँ देइथिला मु एठी देखैली ता छडा आ गोटे बहिरे जदि टिके आमे या विषय टिके डिटेल जदि तमे पढिबाकू चाहूछ फॉर योर knowledge purpose, so एठी भी देखो देइछि optical microscopy. एठी कहूछि it is defined as the formation of a magnified image of a small object using your visible light. And as we know, the visible light is having the wavelength in the range from 400 to 780 nanometer. So for illuminating the object we are using this visible light. Now this optical microscopy is very simple and low cost technique, and hence most widely used for observational instruments. Hans Janssen is said to invent the first compound microscope in Italy at the end of 16th century. But however, Dutch microscopist Antony Leeuwenhoek is regarded as the father of optical microscopy. ओके, अच्छा तापर देखो एठी स्पेसिफिकली कंपाउंड माइक्रोस्कोप विषय रे ये डिस्कशन करिछि. सो एटा हमें ऑलरेडी जानिछु. सपोज जदि कंपाउंड माइक्रोस्कोप रो फाइनल मैग्निफिकेशन हे गला m, then it is equal to image size by object size. Okay, this should be the final image size and this should be the initial object size. So it is also equal to the product of m1 and m2. Here m1 is the magnification of the objective lens and m2 is the magnification of that of your eyepiece lens. तापरे आमे एठी जदि कहबा लिमिट ऑफ resolution which is defined as the minimum distance between the 2 points. Okay, because the objects are here actually like that of your points, so the minimum distance between the 2 points on a sample or an object which can be clearly resolved or distinguished. Okay, so just distinguished as separate, so it is given by theta equal to 0.61 lambda by Na. Okay, but here Na means what? It means the numerical aperture of the objective lens. Okay, so it is defined as sine alpha by n, and here alpha is the half of the acceptance angle of the lens, and n is the refractive index. Remember, n is not a number, rather it is the refractive index of the medium which is filled between the lens and the focal plane. Okay, then one of the disadvantages of optical microscope is its natural resolution limit, which is 200 nanometer as imposed by the wavelength of visible light. So in order to overcome this limitation, we can use shorter wavelength light like that of your ultraviolet or X-rays. Also, we can have another solution. We can use material particles like that of your electrons, neutrons and protons. Okay, so this optical microscopy has several applications such as observation of biological samples, then metallographic observations, then quality control in electronics industries. So if we now try to understand the basic principle of optical microscopy, देखो ये बही रे कन्फाइंड करिकी केवल कंपाउंड माइक्रोस्कोप विषय रे बुझेइछि. सो ऑलरेडी या विषय रे हमें तो देखिला पूर्वरु. सो देखो एटा होची यार स्कीमेटिक डायग्राम कंपाउंड माइक्रोस्कोप रो. तापरे देखो नेक्स्ट सेकंड पॉइंट रे कहूची डिफ्रैक्शन आउ एबेज थ्योरी ऑफ इमेजिंग विषय रे. डिफ्रैक्शन विषय रे तमे जानिछो, this is the central or primary maximum followed by the secondary maximum on either side, then at the bottom we are having the secondary minima. Okay, तापरे जो important condition रहिबो तमरो सेटा होची Rayleigh criterion of resolution, according to which, as you can see in this figure, the primary maximum of object 1 should fall on the first secondary minimum of object 2. Similarly, the primary maximum of object 2 should fall on the first secondary minimum of object 1. So, as per Rayleigh criterion of resolution, the two nearby point objects are just resolved, means just distinguished as separate, if the distance between the intensity maxima in their images is at least equal to the distance from the central maximum to the first minimum, that means the first secondary minimum in one of the images, right? And this distance is nearly equal to m lambda by 2, and this will give you the limit of resolution of the microscope, and thereby the resolving power will be the reciprocal of this limit of resolution. Okay, तापरे नेक्स्ट फैक्टर जदि आमे देखिबा लेंस रो डिफेक्ट उपरे भी डिपेंड करूची. ओके, देयर आर वेरियस डिफेक्ट्स present in the lens and it can cause your aberration or distortion. Okay, so spherical aberration अछि, तमे पढितबो या विषय रे +3 रे. chromatic aberration अछि, astigmatism भी अछि, सेटा गुटे होची तमरो ए सब जते lens रो defect information of images. Then the next factor is the sample preparation. So आमे sample को को हिसाब रे prepare करूछु ता उपरे हमरो result depend करूची. Okay, if we carefully prepare this sample, then obviously we can get better quality results. Okay, and it can make the interpretations easy. Finally, next factor rohuchi amara image contrast. So contrast means it is the variation in the local intensity of light in the image plane. So optical microscopy re contrast jo rohita hai, it can occur due to absorption and scattering of light by the sample. So the parts of the sample that will absorb very strongly, obviously it will appear dark in the image, and those which scatter strongly will appear bright. So an object will appear bright or dark depending upon how it was prepared and how it is illuminated, right? Finally, we can see some of the secondary factors which can affect the resolution, like that of your type of specimen, then coherence of illumination, then degree of aberration correction, and contrast enhancing methodology. So this is all about your optical microscopy, and you can prepare your note by summarizing all these data that I have given in your PDF. Okay.
Thank you.